In this video, I am going to solve electrical network using node analysis. Okay, so this is a question given. So you have a network given, and the question is to find the values of currents I1, I2, and I3. Okay, so let us start with the problem. So before going on to solving this problem, we know nodal analysis is based on Kirchhoff's current law. So Kirchhoff's current law states that the sum of currents at a junction is equal to 0, or otherwise you can say the sum of incoming current is equal to sum of outgoing current. Okay, so let us assume that all the currents are moving away from the nodes. Here in the diagram, the circuit diagram, it is marked, two nodes are marked with voltages V1 and V2, and currents are marked I1, I2 and I3 for the measures. So we are supposed to find the currents I1 and I2, I1, I2 and I3 using nodal analysis. Okay, so let us write the KCL. Let us apply KCL at node 1. Okay, so KCL at node 1. So what is that? It is the sum of the currents at that particular node is equal to 0. So when you see this V1, we can see that three branches are connected. One branch is consisting of 2 ohm resistor. The second one is with 5 ohm in series with a 25 volt battery, and the other branch is having a resistance of 10 ohm. Okay, so we'll be just adding the currents because we assume that all the currents are moving away from the node. So let us find the current through this 2 ohm. 2 ohm is nothing but applying Ohm's law. We'll be getting V1 by 2 is the current through that 2 ohm. So then the second current, it is V1, that is the current through 5 ohm resistor, that is V1 minus 25 upon 5 will give you the current through 5 ohm resistor. Then the current through 10 ohm resistor, again Ohm's law, V1 minus V2 upon 10. So this is equal to 0 according to the Kirchhoff's voltage law. So when you simplify this equation, you will be getting the equation as 0.8 V1 minus 0.1 V2 is equal to 5. So this is our equation number 1. Now what we do, we will be applying Kirchhoff's current law at node 2. You can see at node 2 again three branches are connected. One branch is having 10 ohm resistor. The other one, okay, here I have not marked the resistor. Okay, here it is 2 ohm. Okay, and the third branch is with 4 ohm resistor. So we'll be since we have taken all the currents are going away from the node, we will be taking KCL at node 2 by taking the sum of all the currents. So KCL at node 2 will give you KCL at node 2, it is V2 current through 10 ohm is V2 minus V1 upon 10 plus current through 4 ohm, that is V2 upon 4 plus current through this 2 ohm resistor. So it is V2 minus, since this voltage source is in opposite direction as the current, so we'll be just writing it as V2. We have to take a negative sign there. V2 minus 50 upon 2. This is equal to 0. This is our equation, KCL equation at node 2. So when you simplify this, you will be getting it as 0.1 V1 plus 0.85 V2 is equal to minus 25. So this is equation number 2. Now we can solve this equation 1 and 2 for finding the values for V1 and V2. So solving 1 and 2, simultaneous equation with two unknowns V1 and V2. So we can find V1 is equal to 2.61 volt and V2 is equal to minus 29.1 volt. So from this we are supposed to find the values of current I1, I2 and I3. So I1 we know it is minus V1 by 2. Just see here why it is minus V1 by 2. I1 is in the opposite direction, so it is V1 by 2. I1 is going like this, so it is from 0 minus V1. The potential at here it is 0, 0 minus V1 by 2. So that will be getting is minus 260, 2.61 by 2, that is equal to minus 1.31 amperes. Okay, and then I2 we know it is the current through this mesh it is. So we can just write it as it is V1 minus V2 upon 10. So the value will be getting as 3.17 amperes, and I3 is what? The current through the this third one. So it is V2 plus 50 upon 2. V2 plus 50 upon 2. So that is equal to 10.45 amperes. So you got the answers for I1, I2 and I3. This is how you solve an electrical network using nodal analysis. But whenever you are identifying the node, please be careful that the node is the meeting point of two or more branches. Okay. Then if there is no element between, suppose you have two parallel branches and there is no resistor connected between those two parallel branches, means these two nodes merge together to become one single node. Okay, so that you should be careful while identifying the nodes. Now we'll solve one more problem using this nodal analysis. Okay, let us just draw the diagram. Okay, the circuit diagram here. So it is here. This one is one resistor, then one battery, and we have here one resistor connected. Here again it is one resistor connected here. Then a current source is connected here. Okay, so this is grounded, so that is the reference node, you can take it as. So this one is 12 volt and this is given as 4 ohm and this is 100 ohm and this is 20 ohm and this one is 9 amperes. Okay, that is the current source is 9 ampere. Here it is 4 ohm. Here you have a resistor 2 ohm. Here it is 5 ohm. Okay, and this one is V1. We can see that there are only two nodes. It is V1 and three nodes, V1, V2 and V3, because here you can see it is three branches are coming here. So node is identified as the meeting point of two or more branches. Okay, so this is the example. Okay, now what is being asked in the question is find the voltage across 5 ohm resistor. 5 ohm resistor. So where is that 5 ohm? Here you can just see here 5 ohm is here. Okay, so let us assume that all the currents are moving away from the node. So KCL at node 1 will give you here node 1. So how many branches are there? You can see one branch, this one with 4 ohm, which is in series with a 12 volt battery. Then you have another branch with 2 ohm resistor, then another branch with 4 ohm and another one with this current source 9 ampere. Okay, so when you are writing this V1, the KCL at V1, you have to consider all the branches and write the equation. So it is here. The first one, the current through this 4 ohm is nothing but it is V1 minus 12 upon 4 plus node 1. Then this one, the current through 2 ohm, that is V1 minus V2 upon 2 plus. Then here the current through this 4 ohm is V1 minus V3 upon 4 plus one more branch is there, that is this 9 ampere. We assume that all the currents are moving away from the node, so we can add it. Okay, so 9 is equal to 0. Now we got the equation for the first node, and when you simplify this, you will be getting it as V1 minus 0.5 V2 minus 0.25 V3 is equal to minus 6. This is our equation number 1. Now we will be considering node 2. This is V2. Okay, sorry, this is V2. Okay, so considering node 2 and we apply KCL at node 2, we can see three branches are here. So we'll be taking the sum of current through this 2 ohm, this 5 ohm and 100 ohm. Okay, so let us KCL at node 2. We'll be getting it as what is the current through 2 ohm? It is V2 minus V1 upon 2, and current through 100 is V2 upon 100, and current through this 5 ohm is V2 minus V3 upon 5. So that will be taking the sum. So it is V2 minus V1 upon 2. It is V2 minus V1 upon 2, then plus V2 minus V3 upon 5 plus V2 upon 100 is equal to 0. So when you simplify this equation, you will be getting the answer as the equation as 0.5 V1 plus 0.71 V2 minus 0.2 V3 is equal to 0. So this is the second equation. Now we have one more node there, so we have to take the sum of the currents in all the branches connected to this node 3, that is V3. Okay, so you have a branch which is having this 20 ohm resistor, then we have another branch with 5 ohm, another branch with this 4 ohm, and then 9 ampere. Okay, so let us see now KCL at node 3. So KCL at node 3, we will be getting here the current through this 5 ohm is V3 minus V2 upon 5. Current through this 20 is V3 minus 0 upon 20. So V3 by 20. The current through this 4 ohm is nothing but the voltage across this 4 ohm is V3 minus V1, that divided by 4. Then 9 ampere is coming and it is towards the node, this third node. So we assume that all the currents are moving away from the node, and we can see that only this 9 ampere is the incoming current. So that should be subtracted, or we can put it on the other side of the equation. So we can write V3 minus V2 upon 5 plus V3 by 20, then plus V3 minus V1 by 4 is equal to 9. As I said, it is, just see the equation, this diagram, it is like that. Okay, so you got it is, then when you simplify this equation, we will be getting the simplified equation is 0.25 V1 minus 0.25 V2 plus 0.5 V3 is equal to 9. This is our equation number 3. So we have 3 equations and 3 unknowns, V1, V2 and V3. So we can easily solve the simultaneous equation to find the values of V1, V2 and V3. So by solving this, we are getting V1 as 6.35 volt, V2 as 11.76 volt and V3 as 25.88 volt. Okay, what has been asked in the question? Find the voltage across, sorry, here it is across. Okay, find the voltage across 5 ohm resistor. So voltage across 5 ohm resistor, we can see it is nothing but it is V3 minus V2. Okay, fine, we'll just write voltage across 5 ohm resistor is equal to V3 minus V2. You can see that this V3 is a higher potential than V2. That's why we have taken V3 minus V2. So it is like 14.12 volt. We already have the value. So V1, V2 and V3. So we substituted that values to get this one. Okay. So this is how you solve the problems using nodal analysis, and we know for nodal analysis we have to apply Kirchhoff's current law. Okay, hope you understood this. Thank you for watching.